Hello, it's time to place dominoes. Let's play pips. We'll start with the easy puzzle. Okay, we need a 3-cell equivalence region, which will require with the 3. I don't know which way it goes yet, but we'll just put that in for now. We also need a greater than 4, which can only be the 5. So this equivalence will have a 4 in it. Okay, this goes this way. And then the 3 and the negative and the less than 2 go there. Oh no, I have something wrong. Sorry, what did I do? Oh, sorry. I think I looked at the equivalence region and thought it was an equivalence region. I thought those were meant to be equal. Sorry, that was just my ineptitude. So anyway, the less than 2 still needs to be a 1, which goes into the 3. So that's still the same. And then those two 3s go here. And it's what I had, but yeah, I just misread that symbol. Okay, there we go. That was the easy puzzle. Let's try the medium one. Hopefully I don't misread anything here. Right, we have a six-sized equivalence region, which looks like it will use 6s. Could it use 5s? No. Yeah, okay. So the 6-sized one will use 6s, which means all of our 6s are spoken for. And one of the 6s needs to point into the 0 because, so this doesn't go here, actually, it goes here. Because we need a 0 coming out of the 0 elsewhere. We need another 6 pointing into nothing, so we don't know what that is yet. Could we have a 6 pointing into the 2? We could have that. If we had the 6 pointing into the 2, we could then put a double in this equivalence region, which would be either a 3 or a 5. So how many, right, look at this, we've got all these other equivalence regions. So we've got one 4-sized one, that'll be the 5s. One of which is doubled, so one of them will be vertical. Then the 2 other equivalence regions looks like they'll be 1, 1, and 3, 3, which leaves a 2. So we need each of the 1s in the 2. Okay, so yeah, we don't have a 1 in the equivalence region. What did I say? So we have 5s in the 4-sized one. We've got 3s in one of the 2-sized ones, and how does this work? Once again, I really wish I could rearrange these dominoes. So, we've got 4s. 4s go in one of them, and 3s go in the other. That's how it works. Okay, 4s go in one, and 3s in the other. So we don't have any 4 6s, so we can't bridge anything there. Do we have 3? No. No, okay, so nothing can go between the 6 equivalence region and this other equivalence region here. Nothing actually works in that way, which means we need, I think, to double the domino in that equivalence region, which means it needs to be these 3s. Okay, so that's fine. So now we could have a 6 2. No, sorry, not a 6 2. A 6 1, because we need to not overwhelm the 2. And then the other one will be a 4, which will point up to be our other 2-sized equivalence region. Then that 4 goes across to the 5, so we have our double 5 here, we have our 5 6 here. Okay, so I slowed down a bit there, but we made it back in the end. And that was the medium puzzle. Great. Okay, so now we'll try the hard one. Let's see how this goes. Okay, we need at least 5 0 halves. Actually, we need more than that. We need 8 because we've got 2 0 regions. So how many do we have? 1, 2, 3, 4, 5, 6. So we have exactly 8. Exactly 8. Okay. And we have several 2-cell 10 regions, which can be made up of 6 4 or 5 5. I don't think we have any of those in a single domino, which means one of them, so one of them is pointing down into the 0s. So we do have 6s and 5s for that. The other is bridging the gap between the two 10 regions. So that one will need to be, I think, the double 6, because we already know we don't have double 5s, because I've checked for those. So the only other thing that could bridge the gap would be 6 5, which we don't have. So that actually must go there. I'm pretty sure that's correct, which means we now need a 4 0 to bridge the gap here. So that's good. This other 10 needs a 4, and we only have one 4. So that is a 2, and the 2 can't go across into the 0 region, so it must go up into the 5 region. Now a 3 must go here. That could point down into the 0, which we do have, or it could go to the side, and that means nothing to us yet. So I'll have to come back to that. Now our other 10 must be doubled 5s because we've already used our 4. So we have a 5, 1 and a 5, 0. I think, yeah, we can't put the thing we could not do is put the 5, 0 here, because that would result in an odd number of cells to be filled over to the left. So that doesn't work. So this must go here, I'm pretty sure, which means the other 5 points that way, which means our equivalence region is all 1s all the time. So there's 1s, double 1 in there. Okay, what else? We've got 0s. We could put a 0, 2 or a 0, 3 pointing into the greater than 1. It'll have to be one of those two that does it. We do still have a double 0. Actually, yeah, it could go either. Oops, it could go either. Come on, here or across. And actually, that's fine. It doesn't matter which place we put it, because either way, whether we put this here or here, it's just going to change the orientation of whatever's bridging the 0 and the greater than 1. So we can just put that in there. It doesn't matter. What else? Oh, we also have a 0 bridging to a greater than 4, and there's only one possibility there. It's the 6. I think this is the same situation where this could kind of go anywhere. Well, maybe not. I was going to say it doesn't matter if it goes here or here, but no, that's not true. It can't go here, because if it did, we'd create, again, an odd number of cells. So it must go here, which means our 5 needs, the 5 needs a 3. We don't know what that is yet. Okay, but we do have a 0 pointing into a 9. Now it couldn't be the 0, 1, because then we'd have to make 8 in the rest of the 9, and that doesn't work, which means I think that the 0, 1 actually needs to go here, because it can't poke into the greater than 1 because it's only 1. And it can't go in the 5 because it's not enough to make a 5. So I think this actually needs to go there. I also think the only way to make the 9 is with a double 3 and another 3, because those are the highest counts we have left. So the 3 points into the 0. That's all fine. Now the 0 going into the greater than 1 is forced. And the 3 to complete the 5 is forced, which puts our 1 out into that empty zone. And there we go. That all solved, I think, very nicely and logically. That was the hard puzzle pips today, and I didn't embarrass myself too badly on this round of domino placing. There we have it. I'll be back tomorrow. Bye for now.